Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 3152, Spatial Array 2. This question has been asked in NPCI recently 2 times in the last 6 months, and NPCI is the organization who created UPI. Let's have a look on the problem statement. Here they are saying that an array is considered spatial if every pair of its adjacent elements contain 2 numbers with different parity. Different parity means if one number is even, second should be odd, and vice versa. And this is given to us. An array of integer nums and a 2D integer matrix queries. Like this. An integer array and a matrix queries, where every ith query is having value which is from index to index, and our task is to check that subarray from index to index in nums is spatial or not. Okay, let's say in this example queries are given like this. First query is from 0 to 4. 0 is my from index and 4 is my to index. So 0 index in this array is 3 and 4 index is this 1 2 3 4. And now I have to check whether the subarray from index 0 to 4 is spatial or not. Condition for the spatial array is already given, that is spatial array is the one which is having every adjacent element with different parity. And this is what we have to return. Boolean answer array. Every element in the answer array is the answer of ith query. Now this was the problem statement. Let's see what is the answer of this example. Here in the queries, we are given only one query from 0 to 4. Now we have to see from 0 to 4 if there is any pair with a different parity. So if we have a look, first one is odd, second one is even. Fine. This pair is having different parity, and second index element is odd. Okay. Fine. Third one is even. If we have to check for every pair, every adjacent pair, we just have to iterate over the array. Because as we are going in this direction, we are keep on checking whether the adjacent element pair is of the same parity or not. So here every pair, odd even, even odd, odd even, and when we are coming at 6, it is also even. So this is even and even. And this is violating the case. So we are going to return false from this example. If the query was given as like this 0 to 3, for 0 to 3 every pair is odd even, even odd, odd even, then it is going to return true in that case. There is a similar problem to this, which is 3151 spatial array 1. This is spatial array 2. In the spatial array 1, we are just given nums. We are not given queries, and we just have to give answer for query 0 to n-1. It means there is only one query. Okay, so what we have to figure out is, so what we are doing here is, for every query, we are going through every element. We are checking every element, and we have to see whether elements have parity alternately changing. If first one is odd, second one should be even, then third one should be odd, then it is even, like this. So it should be alternate parity from the range of I to j or start to end, whatever. This is the array given to us, and we have to figure out the answer from index I to index j. I will see when that from index I to j the parity is changing alternatively or not. If it is even, then nx should be odd. Then next to the next should be even, and then further it should be odd, like this. So it is a valid spatial array. Now let's try to solve on this example as well to get more understanding. Firstly, let me mark the indices 0, 1, 2, 3. Here this is the nums array, and this is the queries matrix, where we have two queries. First query is from 0 to 2. 0 to 2 means this subarray. Let's check for the subarray whether it is spatial or not. So here the first element is even, second element is odd, and third element is also odd, As the parity is not changing alternatively, it is going to have false as the answer. Now let's check from 2 to 3. 2 to 3 is this. First one is odd, second one is even. Parity is changing alternatively, it is true. So answer from this example is going to be false, comma, true. This is the answer. Now what can be the brute force for this problem? That we are given nums array and queries. Queries are having multiple sub-arrays from starting index to ending index. For every sub-array, we can explicitly check that sub-array is special or not. Check special array for each query, starting to ending. Let's say the first query 1 is this, starting index to ending index. Then how we can figure out that it is a special array? For every index I will check the previous element, whether the previous element and the current element is of the same parity or not. If it is a different parity, then I will return false. If I am not able to figure out any adjacent pair with different parity, then in the end I can directly return true. There is no defaulter in the array. Okay. So how we can achieve it? We can achieve it using an iteration. How I am checking here is I am going from starting plus 1 to end, because first element is already special, no need to check, and I will be starting my loop from starting index plus 1 so that I can check the previous element I minus 1. So for every index from starting plus 1 to ending, I will see that adjacent pair, that current ith element and the I minus 1th element is of the same parity or not. If the parity of the ith item is equal to the I minus 1th item, if those are having same parity, we can directly return false, because we are required to have alternate parity. If first is even, then previous one should only be odd, and if current is odd, previous one should be even. If it is odd, then modulus should give 1. If it is even, modulus with 2 will give 0. So if these are not same, then it is fine. If at any moment, let's say if it is even, both the modulus with 2 will give me 0 and they are matching, and I can directly return false because they are having same parity. So this much is the logic to check whether the array is special or not. And this we can do for every query. Now as we are doing it for the every query, and what is the time complexity of this operation? This operation is a linear operation, so we will say that it is of order of n time. And let's say if we have m queries, so it will be, total time complexity will be m into n. And what about space complexity? Apart from the answers, we are not taking any extra space. So we can say that it is a quadratic time complexity, and we can improve it. Otherwise we are going to get TLE. I submitted this approach, so it was failing for all the n-1 test cases. There was only one test case which was failing. That gave me TLE. So we have to somehow improve this time complexity. So in the brute force, what we did is that for every query starting to ending, we checked whether there is any ith element which is a defaulter or not, which is disturbing it from becoming a special array or not. It means there should not be any element who is stopping it from becoming a special array. Let's say from 0 to 2. This is the array. Indices are 0, 1, 2, 3. This one is even, this one is odd, this one is also odd. So when we are coming at 0, it is even, that is fine. When we are coming at first index, it is odd. Odd, previous one is even, so it is also a valid item. When we are at 2, 2 is odd and previous one is also odd, so 2 is a culprit. 2 is not a good item, it is a defaulter. So if in the range, if there is any defaulter count is greater than 0, we can directly say that this range is not going to give us a special array. Okay. And if I talk about the 2 to 3, from 2 to 3 it is odd and this is even, and there is no element which is disturbing it from becoming a special array. So defaulter count we can say is 0. 0 defaulters are there in the range, so we can directly say that this is a special array or not. So what we can do is we can capture, or somehow if we are able to figure out how many defaulters are there in the range, we can directly say whether it is a special array or not. Let's say I am giving you a magic function that can give us whether in our starting to ending range there is any defaulter or not in the constant time. Then how much will be the time complexity of the whole scenario? We have m number of queries, and for m number of queries we are going to apply this operation. So every operation is taking constant time, so m number of operation will take order of n time. Now if we are able to do some kind of pre-processing, that pre-processing is going to give us whether the given range is able to give us a special array or not in a constant time. Then we will be able to reduce our time from quadratic to linear. So let me tell you how we are going to do that. For that, what we will do is we will maintain some kind of prefix. Now we will be filling our prefix array, and prefix array from 0 to I is going to give us the number of defaulters, number of elements which are stopping from becoming a special array. Let's say for index 0 is already a special array, so 0 will always be a valid item because it's only single element. Now we are at index 0, 1, 2, 3. We are at index I. What is the value of prefix 1? Prefix 1 value is, we will see whether the current element, whether the ith element is defaulter or not. If ith element is defaulter, then we are adding one more defaulter to the number of defaulters from 0 to I minus 1. So here 4 is even and 3 is odd. So 3 is not a defaulter. Total number of defaulters from 0 to 0 will be the answer. So here in this case, we will also have 0. Now when I am coming to 1, 1 is also odd. And previous one is also odd. So 1 is a defaulter. So 1 plus total number of defaulters from 0 to 1 index, which is 0. So 0 plus 1 will be the answer here. So prefix of 2 is 1. What is prefix of 3? Prefix of 3 is number of defaulters from 0 to 3, and 3 is even and previous element is odd. So this is not a defaulter. So answer would be 0 from current element, and from previous element how many defaulters we are having? 1. So value at prefix of 3 will be 1 plus 0, which is 1. Now we have our prefix array ready, and we can directly tell in order of one time that whether the range from starting to ending is a valid or not. We were having two ranges. For the range 0 to 2, this one, how we can tell that how many defaulters are there in the range of 0 to 2? It is a prefix array. So this value is giving me the defaulters from 0 to 2. So what I can directly say is the prefix of ending minus prefix of starting will give me the answer. Prefix of ending is 1, prefix of starting is 0, so it is 1. That is, in this range there is one defaulter. If it is a one defaulter in this range, we can directly return false for this. And what about the second range? Second range is 2 to 3. 2 to 3, it means this array. 2 to 3. This array we have to see. Number of defaulters from 0 to 3 is 1. And number of defaulters from 0 to 2 is 1. And from 2 to 3, 1 minus 1. 1 minus 1, which is 0. So from 2 to 3 there is no defaulter, so we can directly return true in this case in a constant time. Once we are done with this pre-processing of calculating the prefix, our query result will be the constant operation. Now what is the time and space complexity here? Time is every query, m queries we are able to figure out in constant time, order of one time for each query. And as a pre-processing, I iterated my array n times, initial array, to calculate my prefix. So it is a linear time and both values n and m can go till 10 power 5 as per the constraints. So we can say that n plus m operation we are doing, or you can call it n, whatever you want. What about the space complexity? Space complexity is order of n because we are taking prefix array. So it is a linear time operation. So we are able to improve our time complexity from quadratic to linear using a prefix array. Now we'll code this approach. I need a boolean array to store my answer. Boolean array of size n, which is, let's call it m, queries.length. Now I will be preparing prefix. Prefix is my integer array, new integer, and prefix array is going to be of size n, where n is the length of nums array. Prefix is 0 is already 0, and we are starting filling from index 1 till n. Firstly, we will see if the parity is same for current element and previous element. If parity is same, it means that current element is a defaulter. Then prefix of I is going to be equal to 1 plus prefix number of defaulters from 0 to n minus 1, I minus 1. So this is the case. If this is not the case, if current element is perfectly fine, then prefix of I is going to be equal to prefix of whatever is the value at I minus 1. Now prefix is stored. Now using prefix we will be able to get answer to our every query in constant time. So now I will be iterating over my queries. I equal to 0, I less than m, I plus plus. For every query, what is the starting queries? I 0 is the start, and end is the queries I 1. Starting to ending, and boolean answer of ith query is going to be equal to prefix of ending index minus prefix of starting index. This prefix of ending minus starting is equal to 0. It means the answer is true, otherwise false. Or we can directly say this is going to store this value because this expression is giving me boolean. And in the end I can return my answer because we have captured answer of every query. Let's try our sample test cases. Submitting the problem. It is submitted successfully. I hope you have understood the approach. In case you have any doubt, you can comment down below. Thanks everyone. Bye bye.